You spoke about AAC blocks. So when we speak about AAC blocks, these blocks have a high water absorption rate. So this absorption is likely to cause fissures in buildings because of expansion during absorption and contraction when water is lost. So how do you think AAC blocks can be designed to address this issue?
See, when you talk of AEC box capillary suctions, it is not true totally, because when you take the structure in hand, it has got matrix, there are a lot of pores are there, micropores, macropores. So when you take a piece of AAC block and just, pour water on it, there will be immediate suction of 10 to 20 mm. After that, there is no capillary section. Unlike your solid concrete block or any brick, there is a continuous. The pores are continuous. But in AAC, pores are not continuous, because of the aeration process and also when you do a high autoclaving steam curing. So because of that, even though the surface penetration is there, because the pores are open, because when you do a wire cut, just imagine how semi-spherical these things are there. So it will absorb 10, 20 mm. It won't allow the water to go through that, first of all. And when you use this AAC block, this is a replacement for or is alternative for any walling product. So when you join this product with a conventional cement mortar or polymer based mortars, and then you do a rendering coat, so there is no probability of as such suction. When you keep it exposed, it may happen the size is bigger here. 600 by 200, the surface area is very big in comparison to any other alternate walling material. So water mat, sit through the joints. But these days, most of the jobs are being done, using polymer-based mortars. So 3 to 4 mm joint is that virtually two blocks are glued and sitting one after another. So there is no space to water to seep through. And when you do a rendering coat, plastering coat, that is further minimum. Even we have got documented report, in fact, from CBRI. So if you take a ASC block work and you keep it unrendered, it is exposed. So it is safe for 420 mm of rainfall. And when you do a coat of plastering, rendering or any kind of rendering, you do it, it is safe for 1600 mm of rainfall. So this is very hypothetical in no situation that you will encounter a situation where it will continuously, because there is no ponding effect. It will hit, it will fall down. So I don't think there is any such problem as such. Out of my own experience of 28 years, I'm into AAC. We haven't had that any such complaint we have received in those nature, unless the joints are being filled up properly. So there is a probability of water may seep through that, and that is also in the exposed conditions only.
So I move on to my next question to Dr. Sanjit. When we speak about, decarbonization and all that, so how do you think carbon storage in concrete is paving the way to green concrete? Because I think
So if
currently carbon storage is gaining momentum. So
yes,
can we, yeah.
so if we talk about your typical concrete, the normal cement reaction when it takes place, it releases calcium hydroxide. The terminology they use is Portlandite or lime. So that is released inside the concrete as a part of the chemical reaction of the cement. So this has the capacity to absorb CO2. It not only just absorbs CO2, it also improves the properties of the concrete. So a lot of researchers are advocating that this carbon capture inside the concrete will not only like just reduce the net CO2 emissions, but also this improve the properties of concrete. But when we are looking about this, there are two things that people should understand. That first is that the concrete can absorb a fixed amount of CO2. It's not like a very large amount of CO2 that can be absorbed. To the best and extreme cases, we have observed up to 50% CO2 of net emissions can be offset by this absorption strategies. And second is that the whatever this carbon storage strategy we are implementing, it itself has their own carbon emission processes. So a lot of researchers that have been following conventional carbon capture then sequestration process have not found successful results in this domain. But there are various coming trends which have shown that other strategies where carbon capture is directly not taking place, like people have demonstrated then when near fly ash, the thermal power plant, then this CO2 is already being emitted. They place their concrete near when they're producing bricks over there or blocks over there, precast elements. They just pass the fume through this concrete, so they are not separately capturing the CO2. They're just passing the emitting CO2 through this. This itself produces high quality concrete and captures a significant amount of carbon. So this carbon capture has a lot of potential. It's just that the what strategy we are using to capture this carbon and storing it inside the concrete, that makes the difference. Like one of our recent research, we have not demonstrated on concrete. We have as of now demonstrated in mortars only. But why when we are using this carbon capture with the help of bacteria, we have achieved about 43% lower effective carbon for mortars only. So we are further developing. So like this kind of like that method what we are using for carbon capture and storage, that will play the role.
Okay, I guess not. Okay, so I move on to my next question to architect Sugeet. So you spoke about technologies that can reduce, dependence on concrete. So how do you see the current construction scenario move away from heavy concrete dependent construction? Do you think it's practically possible, or what could be the strategy or for large scale reduction?
So some of this has already been taking place by, let's say, private innovators or architects. Some of them have already been doing it. Now, the question is, how do you upscale this? Now, I believe one of the major things that can happen is that there are many government schemes such as Pradhan Mantri Awas Yojana, which has a different for urban as well as for Grameen. I believe one thing that needs to happen is the government needs to realize that they cannot align their own goals of let's say reducing carbon emissions by to the or achieving net zero by 2070 unless they take these materials seriously, and their own these schemes should be able to adopt these technologies. So I mean, Pradhan Mantri Awas Yojana Grameen is usually houses made from either just ground floor or ground plus one. These technologies are absolutely tailor made. In fact, we have done a study and they will improve a lot of the livelihood issues as well. If you a lot of these technologies actually use agricultural waste into these, and these agricultural wastes directly then you can directly use them. It will bring livelihood, it will stop the burning of some of these agricultural waste that exists. So it's really, I believe, the starting point has to be the government that has to take place. But also we also did a study in which we found the skilling centers are not talking about these technologies. They're just usually talking about concrete or bricks and just that, and that's, you certified a mason and say 3 months of course on how you've been able to make a brick structure, and that's fine, that's good enough for you. And all of these technologies have gone to waste. So it also needs to be a push from skilling centers, which needs to push some of these technologies so that people, masons, are actually working around with these.
Okay. So anybody else wants to add anything? Yes, Dr. Priyanka.
Just to add to what Mr. Grover just said. So one is, of course, skilling is important. I think we also need to put our minds to make business models, because if it is workable economically, whether from the supply side or for people investing their time in designing or using such skill, putting that skill on work, I think it's very important to support and develop strong business lines around that, for which we will also need clarity on supply chains, material banks, like I mentioned. And I think that is a crucial aspect which should also be considered.
Okay, fine. So
Can I-
anything else? Yes, Dr.
So to add to the existing point, like there was one effort made by CBRI in this regard. They had releases a compendium of technology, like a book called Pehel, where they just in to support this Pradhan Mantri Gramin Awas Yojana, what they did, they released a series of house designed material selections, what are applicable in different districts of different parts of the countries. So they released the book highlighting at least 4 or 5 different house designs, different material selection which can be done and which can more sustainable than conventional construction. They even give the pricing models to how these houses can be constructed, what cost economics will go through under different parts. But the sad part is that whenever Pradhan Mantri, even if we someone visits that Pradhan Mantri Awas Yojana page, this documentation under done by CBRI was done under the Pradhan Mantri Awas Yojana only. But when people visit the website, this information is very buried in the text. People usually don't know where to find it. There is very less awareness about this. This is very important. This information that this whenever the training skilling centers, like Sugit already said about that, this information needs to be there for the people so that they can learn and actually implement these technologies.
So my next question to Dr. Priyanka. So we speak about regulations and policies. I think you mentioned about it. So as far as India is concerned, what do you think are the regulations that limit the use of alternative raw materials and alternative materials to reduce clinker usage?
See, so in India, I think there are two bodies. One is BIS, which is looking at the quality while allowing controlled alternatives to cut clinker. And the second body is CPCB, which handles the emissions for co-processing. I think the idea is to look at both of these bodies, and um, there are trial burns, there are emission caps, there is some work which needs to happen in this area. Basically, there is a cap on, say, using 35% fly ash and 70% slag and so on. But a lot of testing needs to be done before such policy can be informed. So I think just people who are doing these kind of experiments, they should inform the policy before it is getting institutionalized.
Anybody else has any other points to this regarding the policy of the
I just want
guidelines?
to just want to share two things. Like when I started my PhD, at that time I did an extended legal policy review of how Indian legal framework allows material selection and their usage. So I found there are two sub clauses in the formation of BIS. One is that, like, I want to like people know about this if they're planning to use these green materials and alternate materials. One is the provision guidelines that are given about product appraisal certification. So there's a scheme under BMTPC called PEC. So whenever there's an alternate material, you can just send that material, get it certified by BMTPC, and even if their IS code is not available, this material is permitted to use under construction, and all legal, like all policies allowed the use of it. It means they have separately issued this has been, I think this was introduced way back in 2008 or something, I can't remember the year. But even then, after 10 years of its implementation, only 12 or 14 products have utilized this scheme when I reviewed this policy at the first time. So people should know, like, whenever they're saying this, we have a greener material, they can just get it certificate approved and all the construction agencies can use it directly. And the second is that they have when people talk about IS codes, most probably when people use this IS code for concrete, they usually use 456. In the buried print of 456, it states that if all the technical specifications have been met, engineer can bypass the use of IS code and use these materials in construction. So people should know, like, if they have a like validated test result, they have confidence on the technology, they have sufficient data to support their like material. They don't have to wait for the specification limits that are defined in IS codes or CPCB. They can directly use these materials. They just have to attach the test result with this material.
Okay, great. I think awareness is what is more important. So I have one question for Rajdeep sir. Again on AAC blocks. So when we speak about AAC blocks used in construction, so can these AAC blocks be used for large scale infrastructure like bridges, tunnels, and dams? And can their durability and strength be
Sorry.
Okay,
So
yeah.
AAC blocks are primarily to be used in building, any kind of building. So when you talk of like such infrastructure applications, not directly on the pavement or the crash barrier, in those places you cannot use, because every product has got its own set of merits and and the place of its uses. So while you can use it for as a sound barrier, you can use as a tunnel backfill also. Interestingly, I just want to mention DMRC, when you're constructing underground sections in Delhi also, what they did before they construct this tunnel, Then there's a backfill, soil backfill. They're putting this waterproofing things, to this concrete. So after backfill, they have created lining of AAC block work. The idea is that you're concerned, the first question you had, that porous. So what is the benefit was there when you create near to the backfill, this AAC block, if there is seepage, anything from this, the groundwater in the underground section, it come, AAC will absorb it and keep this, okay, hold it. It won't let this, pass it through. It takes hell of time. So in such situations, when there is waterproofing membrane, you're putting it near to the RCC, structure, the tunnel portion or any kind of things, it is protecting. So it can be used as a protection layer for tunnel also. It can be used along the highway. In abroad, most of the places you will find these panels because they're light in weight. So you can easily erect it various heights, with using a steel frame. So that will also reverse the sound. It will absorb these things, So you can use it for those applications, and also any administrative buildings like in the toll plazas, you have got the booth and those kind of buildings. This can be used, but not directly as an infrastructure application like crash barriers or the road pavements and will create like those places. It cannot be used directly.
Okay, thank you for that insightful answer. So just to continue with the question, when we speak of green concrete, do you think green concrete is on par with traditional concrete in terms of durability and strength to be used in, large scale infrastructure?
So when people are saying that, like when we are talking about green, it's already many of the materials that have come into the picture. They have already demonstrated better durability and mechanical properties, and they have already gone for commercial application. Like when people talk about fly ash based cement, PPC cement, it showed that it can show a good quality result. That's why OPC cement was replaced over the period of time, and now it has become a standard practice. And if we talk about, there's a new type of cement that is being coming, that was, I think, probably developed by IIT Delhi and IIT Madras joined with an international team. It's called LC3 cement. So it is also showing a very good quality in terms of durability, and it is far more sustainable than OPC cement. So it's recently introduced in the standards and is now being introduced to the market. So it's not like in many cases, green materials can be more durable. Like in case of many of the cases, geopolymer has shown better durability than normal concrete. So correlating green material with durability is not necessarily. When a material which is already green meets all the durability and all the technical performance, we can directly call it becomes a mainstream material. But in some cases, when the materials is behaving green, but it does not meet the all the necessary durability requirement, it happens in some cases when the performance becomes slightly weaker in some cases. Like if you talk about, there is a ongoing debate that whether a higher amount of clinker substitution should be allowed in concrete or not. So there was a point raised by some of the bodies that when higher amount of clinker substitution is there, the risk of corrosion increases. So when we talk about this point, these kind of concretes can be used for cases where durability is not affected. So like if you are inside of a house, you can always easily adopt for higher clinker substitution. So green material is durable enough, and it's just depending on the application you are selecting. The material can be like used or not.
Okay, great. So, my next question to you only, Sanjit. So, you speak about, you spoke about recycled aggregates. So, these recycled aggregates, when we speak about them, they generally vary in terms of strength and quality. So, how do you think standardization can be achieved for concrete in terms of strength and quality when we use recycled aggregates?
So it is more about defining the responsibility. It's like there are three pathways which are typically advocated when we are using we are talking about standardization of recycled aggregate. First is at the source, like when people are like generating this waste, if they give sufficient information what kind of waste is being generated, people can already have an idea what kind of strength and what kind of substitution level we can expect when we are using in concrete. Either they can take the responsibility of documenting the kind of waste they are generating so that its recycling can be made easier. The second intervention that is expected is as at the recycler. Okay, even if the waste is not being received from of known quality, typically test can be conducted and the recycler can process the waste in a uniform quality material. Like people already recycle it in the form of paver blocks. So the paver block end properties, it's the recycler, he's making sure that the end properties are achieved. At that point also the material is giving the standard behavior. And then the third pathway is that the construction agencies need to be trained, like they can always conduct the standard tests that are given in codes of there's a people, while we are aware about the IS 383, that's the code on aggregate, they have included a detailed section regarding recycled aggregate, and there are other foreign codes also which have covered in greater details how the standardization and testing needs to be done. So it's about which of the three key players are we able to convince first. So government has been trying different strategies. As of now, the second strategy is being more effective in our context, where the recycler, they produce this waste aggregate and they make some standard products which is meeting its final requirements. So they can produce bricks, blocks, which already are meeting the desired properties, and the engineers can directly use them without any worries.
Okay, great. So I think I have a common question to all of you. One is like, when we speak about adoption of green concrete in India, do you think right now the awareness is increased, but do you think, or what do you think are the challenges to the adoption of green concrete in India? And how can these be addressed?
One example, say 30 years back, when you got this AAC block in India, so it was everybody was appreciating on the face of it, it's a good product and everything, all features, everything is great. But the next question, there is no other manufacturer. We are the sole manufacturers then. Then the government, they said, no, monopoly product, he cannot use it. But this is chicken and egg story. He can't wait for other things to come. When it will come, then it. So at least, first 3 years, 4 years, there is no taker, only few projects. Then it's gradually started taking kind of. So this is one sort of challenges. Even though the product has got all the merits, but looking at it, all the the aspects like all administrative issues, particularly for the government projects. Private still okay, they can take this month. Nobody can challenge you, as Dr. Sanchit and Dr. Sujit was mentioning that you've got all these parameters, you're fulfilling all these criteria, even though you do not have the code, that can be done. So coming back to the same issue now, we got hold on another technology now. That's available in Europe. What is happening when you construct a wall? So now we're talking of net zero, green and clean, say water, those things are moving around. So when you construct a AC block, it doesn't require any pre-curing or it's already steam cured, do not require any post-curing. Now these days, most of the project they're using polymer-based jointing mortar, that is also doesn't require curing. But what is happening? So when you construct a wall, you have to put a RCC band in every 1 meter to create the tensile capacity, improve the tensile capacity of the wall. So there comes the cost in situ. India is going vertical. Just imagine you're doing a 10-story, 20-story building, you're taking your steel, your concrete, you expect it to cure for, post-application of then de-shuttering. So that's a huge problem. And if you do not provide, then there is a performance issue because the wall may not perform the desired way. So we got hold of a technology. It's again a proprietary product of Messrs. Beckert. They've been doing it for last 10 years in different form. So, and it comes in a road. It's a mesh, very high performance steel mesh. So what you were saying, AC block wall, then you just roll this mesh, cut it, and then you push the block jointing mortar, then go for the block work, next block work. So you do not require any concrete band like this. It's a replacement for RCC band. So that entire wall you're constructing is a dry. You do not require any curing, post or pre-curing kind of thing. We have engaged with CBRI, CSI CBRI. They're carrying out all the experiment, full-scale testing, and they are performing at that. They've already, this report is about to publish. We've got and what they found, it is performing perfectly well. You can conveniently replace those RCC band. Then you can use this meshes with the same performance. So it's a boon to the construction industry. Again, the entire wall, their productivity will go up. There's no headache of, right doweling being done in not the RCC band and all this kind. Everything eliminated. No cement, no steel, nothing. Only this high performance steel is very high. Because we're using steel of iron 550 or 650 grade. This is our 2100 candidate. It's like very high performance product. So what I'm now envisaging again, going back to 30 years back, single product. There is no equivalent product has got maybe, and now the market is more mature, the industry has evolved, and there is the entire ecosystem is working towards clean green things. Maybe it will help. Otherwise, we can't wait that someone equivalent product will come, then only I'll adopt it. So those challenges will always be there, but it depends on also on the project authority, what part he can take and is take it forward. So just looking forward that industry, like already it has started, in the last 2 years, we're using in different places, we are creating references and kind of things. And very soon, it is getting very good response also from the industry. Thanks. I think that's the insight I just want to give it to you all.
Thank you, sir. Anybody else would like to add anything on the challenges and, to the
So-
adoption of green concrete?
I'll just speak one very simple point. So currently, the use of recycled aggregates is controlled by IS 383, which is one of the codes which really controls that. And majorly, what it says is that you can use these recycled aggregates majorly for non-structural elements, and I think till about M25 you can use it till 20%. Now that is something, as Dr. Sanchit also said, that technology is changing. The aggregates we are getting will get better. So these codes are much behind than many other countries, which allow for a much better substitution. The moment you see this code change, you will see that a lot of concrete substitution or aggregate substitution, which is inside concrete, can be replaced by recycled aggregates. I think that's something that you will see very soon happening and will be a game changer in a way.
Okay, great. Dr. Priyanka, you want to add anything? Dr. Sanchit, you want to add anything to the challenges?
There is one challenge that I would like to take as an example. This was recently shared to me. There was a construction project that was going in Bhopal. So what they did, they used this different kind of fly ash brick for constructing the houses. But what they did not realize that the water movement in that brick was not same as the expected water movement in the previous fly ash brick they were using. So that at the time of testing development, the material they used was way different. But at the time of mass production, the material met the strength criteria, but they did not account for that this can affect the water movement. So when the actual construction took place, the material passed all the brick passed all the tests. But when the construction happened, they realized that the cracks have started appearing, the buildings started showing faults. So this was recently discussed in a BAS meeting that this building is being taken as an example, and they are now trying to update the standards, like this test should also be included. So I'm saying that this kind of challenge happens like when we have a conventional understanding of the material, people are often overlook other properties that may affect the final performance of the structure, but they have not known about it for a long time. So this kind of things happen like when we are making concrete with pozzolanic cement. People always look for strength. They believe it is becoming better. But when we are making concrete with pozzolanic material, it becomes brittle. There as of now there is no understanding that brittle material will cause a significant negative aspect. But if the concrete becomes way brittle, there might be a chance that we may observe some new observations. So this happens with happens with whenever a new material is introduced, that people will observe challenges, they will improve it. Like Rajiv sir also said that they observe challenges, they improved it. This will keep on happening, but this challenge should be taken as always taken as an opportunity, not taken as a limitation.
Speak about guidelines and standards driving the manufacture and use of green concrete in India. Are we following any global standards, or, are there any indigenous standards that have been developed for Indian market or the Indian consumers?
Regarding the standards, our standards I accept are behind global standards. Like we usually develop standards after the technology has been validated for over 15 years in the field. So and if we talk about some of the European standards and American standards, they usually release the standards within 5 years of testing. Okay, so the standards what the BIS and the other Indian agencies are releasing, they're typically behind. But we should also look, these are all standards which have been satisfied for Indian condition. We are not directly adopting these standards. Like if I take for an example, there is a kind of cement called Portland limestone cement. This is accepted cement in both European and American standards. But the thing is, the limestone quality that is available in Europe and America is way different from the secondary limestone that we are getting in India. So when the same studies were replicated in India, the performance was way poor. So that's why this was never included in the standard. So when that's why it's typically suggested if you are adopting a foreign standards to test the material again in India. Otherwise, it takes 10 to 15 years extra when this standard will be released in India. So yeah, but there are guidelines. Indian government is, in terms of guidelines, they are way faster. There are specific agencies like BMTPC, it very actively releases guidelines. It's like if you talk about bamboo construction, I think they released like technical guidelines way earlier. Even the standards were not there. Even globally, the standards were not there on bamboo construction, but they released guidelines how to do it, what kind of test we have to perform. In case of like recycled aggregate utilization, they released their initial guidelines on how to use it. I think that was released in 2002. And similarly, like these agencies are there, they release guidelines ahead of time. So if the construction agency can take these guidelines, like there is a more awareness about that the construction agency can follow these guidelines, we might not wait for need. There might not be a need for waiting for standards to come before these materials can be implemented.